Next, we need to attach the 12-volt power supply to the back of the E-DWT. When attaching the 12-volt power supply, you will see that the RPM4 begins to initialize. Your indication that the RPM4 has fully initialized is that on the ready indication here, it will turn green. Now I want to describe the purpose of these three valves. First, we have the reservoir shutoff valve. The reservoir shutoff valve isolates the reservoir from the variable volume and the device under test. Then we have the low pressure isolation valve. The low pressure isolation valve only exists on E-DWTs that have 2 QRPT. QRPT stands for Quartz Reference Pressure Transducer. These are the reference measurement devices that are within the RPM4. The purpose of the isolation valve is to protect the low pressure QRPT from seeing the pressures that you will be achieving on the high QRPT side. Next, we have the test shutoff valve. The test shutoff valve isolates the device under test, your gauge, from the variable volume and the RPM4. This allows you to maintain a pressure on the gauge while pulling more fluid in on the variable volume to give you more capacity for larger volumes in your test gauge. Now we are ready to calibrate the gauge. What we need to do is put the valves in the correct orientation and back out the variable volume. Now we need to position the reservoir shutoff valve so that it is open. To open it, we want to go in the counterclockwise orientation. It doesn't have to be fully open, it just needs to be open enough to be able to pull fluid from the reservoir into the variable volume. Low QRPT isolation valve needs to be in the clockwise orientation to select the high transducer. Isolate it from the low transducer so it is protected. We are calibrating a 10,000 psi analog gauge, which is the full scale of the high QRPT. Then we want to go to the test shutoff valve and make sure that it is fully closed. That is in the clockwise orientation. Now we want to extract the fluid from the reservoir and fill the variable volume so that we have the maximum stroke for when we go to calibrate our gauge. We also want to orient the test shutoff valve so that it is closed. Closed is fully clockwise. It does not have to be fully tightened, it just has to be snug. Now the valves are in the correct orientation to pull fluid from the reservoir into the variable volume. To pull that fluid from the reservoir into the variable volume, we can go counterclockwise on the handles. You can see how easy this is. It takes one finger to go back. You can go pretty fast until it stops. There's an indication, a variable volume position indication on the top of the electronic deadweight tester, which will give you where that stroke is for the variable volume. Right now, it is backed out all the way. Now we are ready to attach our gauge. To attach the gauge, we want to open the plug on the test port of the electronic deadweight tester. Note that there is also a test port on the back of the electronic deadweight tester to be used for other devices. We have already attached the correct adapter to the 10,000 psi gauge and simply place it on top of the deadweight tester and have it a little less than finger tight. Now we need to make sure that we don't have any gas in the system. Gas is a very compressible fluid, so when you use a variable volume type of system, the more gas you have in the system, the more gas that you will have to compress. It's to your best interest to remove as much gas as possible. Well, the electronic deadweight tester has a feature to help in that process. It's the priming pump, sometimes called the plunger, on top of the reservoir cap. Right now it's fully extended. If it's down, we can pull it back up so that we have a maximum stroke.